Emanuele and Giacomo that we will talk about the FDAP stack. I don't know what it is, so I'm really curious about. So a big round of applause for Emanuele and Giacomo.
Thank you.
And this time, question at the end is not interactive. This talk.
Okay, if you have something urgent, you can interrupt, but the question time is at the end. Okay, so let's introduce us. Can you hear me?
Yes.
Okay. I'm Giacomo. I'm a software engineer in Hiop. Emanuele is my colleague. We are a deep tech startup founded in 2020, started from a group of university researchers, and we work in the data engineering field. Today, we will talk about, of course, the FDAP stack, but we will introduce some data concepts. Then we will talk about big data, and then how to implement it also in distributed systems. So let's start from the data concepts. Two approaches, data warehouse and data lakes. There are two ways of storing data. Data warehouse, typically databases. They store structured and clean data, are designed, of course, for analytics, reporting, for dashboards. Another approach is data lake, where you store not only the final clean data, but also unstructured data, semi-structured data, or even files, text files, audio files, images. It's designed for data science, and some examples are, for example, AWS buckets or alternatives. So data warehouse usually follow the ETL approach. So you extract the data, you transform the data, and then you save only the clean data with the validated schema, everything after the transformation. That has a lot of pros. You can query it's perfect to be queried because the database, of course, contains the engine to query the data, and everything is on the same place. The other approach is the data lake, which has restructured the ETL before transforming the data. It loads the data. It loads also and stores also the raw data, and then the transformation happens later. This also has a pro that is cheaper than databases, but of course there's a cons that the data cannot be accessed directly because, of course, it's file, not easy to query. So what data engineers invented an hybrid structure which try to take the benefits of both. That is data lakehouse. So they put some rules to use buckets as main storage, but then maintaining ACID transformations, put a schema and enforce schema to maintain the data in order to do database-like operations. What are the most common formats? Delta Lake, introduced by Databricks. It's quite simple to use because it doesn't need a data catalog. As a cons, has a limited schema evolution, but the alternatives are quite popular. Iceberg from Netflix. It's a little bit harder to set up because you have to set up a data catalog, but it's then more flexible for other features, for example, the schema. An alternative, it's also Apache Undi, created by Uber for continuous ingestion. That is more similar to Delta Lake, if I can say. and similar to Delta has limitations with the schema, but it doesn't need the data catalog too. So a little bit of the history in 2016, from 2016, Undi and Iceberg emerge to fill the lakes, basically. Then from 2019, Databricks introduced Delta Lakes, and is nowadays still used by them. And then from 2023, also Iceberg continued to grow because it's now supported from all the major engines, Snowflake, AWS, Google, etc., etc. Okay. Like someone said, no, that's not true. Big data is dead. But why? This was an old slide by BigQuery Sales to try to sell a BigQuery to scare the clients that the amount of data will grow exponentially. So they have to buy BigQuery. They have to buy BigQuery fast. But the reality, it's a little bit different. Why? Not because the amount of data is not growing, but because not only the data was growing, but also the power of the machine was growing, and also the price was lowering. So if 20 years ago an EC2 was 2 gigabytes of RAM, now, as you can see on AWS or every cloud provider, this story it's very different. Yeah, that's the scale. Okay, not only the data indeed increased, but also some considerations. Most of the company doesn't have more than 1 terabyte of data, so it's manageable, more or less, in different ways. The median, it's about 100 gigabyte, and super interesting, the most of the queries are less than 10 gigabyte. So 10 gigabyte maybe can remind you something. So key takeaways. It's more important to optimize for the common case rather than the worst case, because data usually go on dashboard, and we need to implement for everyday cases. Even if, imagine a big company has 10 years, 20 years of transaction, most of the time, most of the days, we do not query 10 years of transaction, but only last week, the last month. And maybe you can implement a doc analysis for these cases. What is also important, since it's really rare that we scan the whole data set, all the columns, it's really hard to do a select star, for example. It's important to have columnar scans implemented, and how to get the benefits from these by reducing I/O serialization and try to reduce in-memory copy. Okay, let's introduce an implementation of these takeaways, the FDAP stack, which is basically the Parquet files for the storage, Arrow for the memory, and DataFusion for the query engine, using then Flight as a network protocol. Okay, let's deep dive on Parquet, which is the file format, a columnar storage format. Why is it important? So we can lazy load the data set. Imagine we don't need to load all the table, but only the columns we need. Parquet also supports scheme evolution as an high compression rate, really different from CSV or JSON, where you have to load the full file. You have to scan it all, not only what you need. And of course, doesn't support schema and compression. C, really similar to Parquet, we have Feather, but it's has more limitations with the schema, only light compression, and doesn't support partitioning. That's why Parquet wins in this architecture. One-to-one mapping, so from Parquet Parquet for the storage, Arrow in memory. Why Arrow works so well with Parquet? Because both are column-based, and thanks to the metadata, we can allow lazy loading. And also, it's agnostic to every language, so we can use it also with Python, of course. DataFusion, it's a query engine. Written in Rust, sorry. No, we are Python today. Arrow native, it allows to run SQL queries. And to deliver these, we use the Apache Flight that is built on gRCP, and it allows to stream data. Also optimized for Arrow. So with this AI-generated image, we have the Parquet files as a storage. Then the Arrow when we want to load in memory. DataFusion to do the transformation, and once the plate is ready, we can deliver our tray through Apache Flight. Okay, but let's make it real. We did an experiment by loading a sample data set, which is this. It's the New York taxi transaction. Yeah, in memory, this is 6 GB of data, 41 million of rows. And we did this experiment to load the data set without materializing it, and then materializing it only after the query. So we choose two approaches to materialize the entire data set and then do the query, versus lazy loading the data set. And that's the result. These are 6 examples. The light red is the time to load the full data set. That is always the same, because first load and then do the query. And on the right, in light blue, the lazy approach. Of course, to do the full scan, the time it's more or less the same, but then trying different approaches, for example, a column projection, the time really minimized. Also reading only some partitions. We don't have to read all the partitions with this approach. The time is really lower. And also on a complex query, this works really well. So why this approach is efficient? Because of the lazy query execution, as we saw. Because of the column pruning, so we need to load only the columns we need. Because of the predicate push down, so the way, in the order in which the query is executed, DataFusion analyzes the where clauses before, so can understand what part of the partitions load, and can scan the partitions before loading the full data set. Okay, but what are doing the technologies now? Pandas and Polars integrated Apache Arrow to allow the lazy loading, basically. Also Apache Spark implemented Arrow, and also it's working on supporting Arrow Flight, which is the final part. What are doing cloud players? They all now have support for this kind of files and this kind of Arrow technology. And also now AWS and other players, I think, are doing the same, are introducing a lakehouse kind of lake out of the box. Okay, my example was on single node. Now we will try to deep dive on distributed nodes. And I pass the ball to Emma.
Okay, you hear me? Okay, so as Giacomo showed, it's easy to have zero copy and optimizing queries on a single machine because it's easy to share memory between processes. So if I have a Parquet file, a DataFusion context, another application working with Arrow, they share the same memory so they can access easily. If they use Arrow as a common pattern, they can share easily the memory. This unfortunately is not true in distributed systems, because when you have a distributed system, of course, different machines over the network, they cannot physically share the same memory. So what we can do in this case, because for sure we need to move data, we need to transfer data between machines. What we can do is, using Arrow Flight and other technologies, we can try to minimize this data movement. So we can achieve zero copy inside the single node and try to minimize the copy when transferring data between one node to another. For this, Apache introduced Apache Flight SQL, Arrow Flight SQL. Arrow Flight SQL, it's an acceleration layer to run SQL queries on our database. So we are now talking about SQL on our database. We are using Arrow only to accelerate the movement of data. So typically what happens that we have our database. We run the SQL using the classical ODBC, JDBC driver. This data is then converted to a format, moved through the network, then received by the client, reconverted to a data frame format, and then it's accessible by users. Of course, we have different stages where we transform the data between formats with classical approaches. With ArrowFly, this does not happen because ArrowFlight has the specific connector for the database, and when the server reads from the database, the data is already in Arrow format. And when the data is shared with the client, we directly move the Arrow format. So there is no conversion between types. So in this way, we minimize the serialization. So as we can see, compared to a classical ODBC approach, we directly access the database, the data in the database using the Arrow format and share with the client through Arrow without transforming the data between formats with the classical ODBC. Why ArrowFlight is a win? Because, as I said, we do not convert data between formats. We have near zero copy deserialization when moving the data from the memory to the network adapter. Because if I need to move data between two machines, I need somehow to take the data from the RAM, move to the network interface, and start streaming the data. Of course, this needs to be happen. It's not, this is not totally free, but it's near free thanks to the arrow format. Data is transformed as columnar batches and not as raw batches as typically happens with the normal SQL drivers. And the stream is over gRPC and not classical HTTP 1.1. And in general, common queries are cached because Arrowflight by design has immutable buffers. So if a query is executed in a short amount of time, more than once, he reuses the memory. So to build a flight as a basic flight application is quite easy. We need to concretize in Python. It's always strange to see object-oriented programming in Python, but still. We need to concretize the abstract classes that flight give us and implementing the method to read and to load data. Then we start the server over gRPC. While on the other side, with the client, we connect to the server, creating the client, and we start reading the data. So with few lines of code under the hood, Apache, Arrow, and Arrowflight SQL are doing all these really low-level optimization for us. So what's happening in the world right now? Well, first of all, as Giacomo said before, 99% of query only access at maximum 10 gigabytes of data. These 10 gigabytes of data reminds me the maximum amount of AWS Lambda, for example, that is a serverless function execution, but also Azure Function is 14 gigabytes, so we are quite close. And Google Cloud Run, that is the alternative of GCP, is 32 gigabytes, a bit more, but the timeout is half, it's just 5 minutes. So these can unlock having, using the FDAP stack in a single node, so in a single AWS Lambda function, for example, we can also think about some not very quick analytics because serverless has usually cold start timeouts, so it's not so quick. But if we can do analytics in the order of seconds, well, we can also use a serverless function and not maybe complex data infrastructures. And what is going on in the Apache world? First of all, there is this very important, this cool project, DataFusion Ballista, because DataFusion is a framework to run SQL queries over Arrow format, but it's single node. Ballista is the DataFusion version, but in a distributed system, so multi-node. Oh, sorry. Then we have also a DBC that, as you can imagine from the name, is the Arrow native alternative to ODBC and JDBC. So it's just a driver protocol for databases. And then we have all the Flight SQL adapters because, as I said before, Flight SQL directly reads the data from your database. So it needs a driver, an Arrow native driver to read the data. So there are, of course, for each kind of database, the community needs to develop a driver. And then another very cool project is Substrate, because when working with SQL, well, the SQL query, it's compiled in a query plan and an execution plan that is like the text of the query is converted to machine code so the engines can execute the code. Substrate and every database has its own compiler. So Postgres has his way to compile the query, MySQL has his own way, and so on. Substrate, it's a common compiler for query plans. So what this unlocks, for example, create the query in a single dialect and execute the query in all the database that supports the Substrate driver. It's the same thing that Arrow did with the memory format, but is applied to at query compilation level. So here the roadmap over time of Apache Arrow. I just realized that this year is 10 years of Arrow, so happy birthday. And as we can see, Arrow was the first, then Feather, Plasma, and Grandiva, they kind of died. But DataFusion, after Pydantic start implementing Logfire, is having a lot of contributions, and Flight and Ballista and FileSQL are the most recent, and so also the more experimental ones. So what are we doing with FDAP in Hiop? Well, Hiop is a data platform. So we work with data. We created that platform for data. So optimizing the movement of data was critical, business critical for us. And how we did this? Well, we created a YAML template file to define pipelines. You can think about Hiop like Terraform, but for data. Then we give developers a set of toolchain to creating these YAML files. Well, under the hood, Hiop takes care of taking these files, compiling the most efficient way, and execute over Arrow, over Python and Rust to move your data. But performance are not the only pain in the data world. We have the second big pain of data world. That almost all the company have bad data, and this is well known. Everyone knew that companies has bad data, but well, now they are discovering that they have bad data. How they discovered that they have bad data? Because they are paying consultancy projects to apply AI on their data to have fancy bad data. And this is even worse because when you start automating it, you have a fleet of fancy bad data. So with Hiop, thanks to the declarative format that you can wipe code on Cursor, for example, and the work we do under the hood to optimize using the most advanced technologies to run your pipeline, we think we will solve this issue. Thank you.
Sì.
Okay, any questions? Yeah, first question.
Hi. You said Flight Arrow can actually be connected to any database, right? Like Postgres and potentially MySQL and Redshift, yes, and so on and so forth.
They have the adapter, yes.
Exactly. So, but the adapter is also kind of creating a standard dialect of SQL, or like if I'm connected to Postgres, I'm still using the Postgres dialect.
And the adapter only covers the part of reading the data and move the data to the client. Like the execution
the
of the
actual
query
SQL
happens in the database.
Okay.
So you have to follow the database dialect.
Okay. I have an interesting question for you.
But for this, the substrate solves your
okay.
issue.
Yeah, absolutely. I saw it. But now, you know why Flight is faster by sending columnar and not row by row data?
It's faster not because they send not directly because they send columnar over row data, but because Arrow is a columnar format. So if the driver sends the row batches, Arrow to build one column has to wait all the row batches, then build the column batches. Being Arrow Flight SQL native, with Arrow he starts sending column one by one. So Arrow is able to, I guess, in parallel construct the data frame according to what is receiving, and for this reason, I guess it's more efficient.
But also there is something else. So basically, when you are creating a data structure in a columnar database, you can create a different compression for every column based on the format of the data you are storing there. So basically, transferring the data over a network by and doing columnar, basically you can optimize data because you can compare exactly.
Okay, yeah.
That's interesting.
Yeah. I guess there are multiple answers.
There's multiple answers
multiple
to the
factors.
Same question.
Yeah, exactly.
Thank you.
Welcome.
Any question? Okay.
Hi. On top of this FDAP stack, you always include a table format like Iceberg UD and everything you showed before, or do you think that Arrow can also query directly file formats like Parquet in some way?
Yes.
But in that case, could benefit by the predicate push down as well, only with Parquet?
Less, because if I directly load a Parquet file, a set of Parquet files using Arrow, I have some kind of optimization, but with the lakehouse formats that are always Parquet under the hood, I have more, because the lakehouse format takes, for example, as an index of the Parquet files. So if I need to search a specific partition, like the data of the last month, if I use a lakehouse format, I know where is the Parquet file of the last month, so I can directly load that specific file. For example, if I have a set of Parquet files, I don't know where is the data of the last month, so I have to load all and then searching. There are ways to optimize these also in plain Parquet files, thanks to the Arrow dataset interface. But lakehouse, it's a step over, so it's more efficient.
Okay, then
because they collect metadata about the files, where is what files contains what, so they can index the files for you.
Indeed, Iceberg, as far as you know, collect some trees of metadata like Parquet doesn't, and Arrow doesn't collect any metadata about them.
Exactly.
Okay. Any other question for people? Okay.
Does Arrow Flight SQL do the query optimization lazily when extracting from a database? Because Arrow, I know you can do it from a schema and metadata when reading from a file. Can you also optimize before extracting from a database?
I don't know, to be honest, but I don't think so, because the query is executed directly in the database engine. What Arrow Flights adds is just getting the result from the database and start sending to the clients. So it's more like a network protocol. It's not about application level and execution. So I'm pretty confident that everything related to the query execution depends on the database you are using.
So maybe Substrate could optimize the query in a common language.
Yeah.
And
For
then
example, if you use DataFusion that uses Substrate under the hood, they do. But for example, PostgreSQL, I don't think so. At least not now.
Okay. Thank you.
But I'm not sure. So it's just my opinion.
You, Giulio.
It's a semi-stupid question, but why is PyArrow specifically so bad, in your opinion, in terms of performance? No, not Arrow in general. I meant specifically PyArrow.
I don't know if I can say this here. I guess it's for pi, the pi prefix. No, I mean, because Arrow is very efficient, but unfortunately Python it's not. I mean, Python is not built to be fast, so it's single-threaded. So Python it's always a bottleneck for this very low-level execution.
My specific case was because Polar specifically supports in many methods, IO methods, both ways, like natively Polars, which they have their own Parquet push down and all kind of filters, or PyArrow. And PyArrow is sometimes in some
Because
simple queries unusable while on Polar.
Because the bottleneck is Python that is single-threaded by design.
And this is one case interesting to what he was referring to on the metadata, that sometimes on the, for example, on Polars, I think I tried with Delta, it was using the Delta metadata, and instead the Polars reader wasn't, so it was using just the Parquet, so you had that performance penalty. But Polars was still much faster, despite not having the access to the metadata.
For example, also Delta Lake, since the last measure, they had both drivers, PyArrow and Delta RS, that is the native on Rust. From the measure, the 1.0 version, they dropped the PyArrow backend, and now they use native Rust.
As far as I know, also Parquet files support metadata. They store all the column metadata and also statistics on groups of rows. So if you do like a min-max average, you know which batch of rows to get into the single file.
Yeah, but in the single file, the data lakehouse formats, they add this level of metadata across multiple files. This is the big win of the lakehouse format. And for example, talking about Polars and this Rust, the switch between Python and between the Python library and the Rust backend, it's kind of free thanks to Arrow, because Arrow being language agnostic, Rust, the thread, the process of Rust and the process of Python, they access the same memory thanks to Arrow, and it's because it's shared.
Actually, with the you have been mentioning Athena as well on AWS for the data lakehouse solution. But actually, on S3, unless you don't use S3 tables.
It's the new
format where you can actually load and you create some metadata, blah blah blah. But if you are using just S3 and you have Parquet files in there, you can using partition, let's say the path of the file is gonna work as a partition.
Yeah, the Hiop format.
So the where condition is actually running against the path rather than against the files.
Yeah, that's why I said if you do some tricks with Parquet, you can also
if you do
bypass the metadata of the format, but you have to manually do it.
Yes.
Or when you write,
let's say programmatically.
Yeah, programmatic. Yeah, with manually I mean programmatically.
Okay.
There is no library that does
for free. The same but different.
Yeah.
Okay.
Cool. Okay. Any other question for another question? You don't like pizza? You want to do a question? Okay.
I haven't tried it in deep. I haven't tried it in deep.
Just a quick question. Have you tried DuckDB for this kind of operation?
Yes.
Very similar.
Yes. DuckDB is a competitor of DataFusion. So we have tried DuckDB too. And first of all, it's cool because both DataFusion and DuckDB, they use Substrate. So potentially you can use the same query for both. The difference with DuckDB is that the DuckDB is written in C++, while DataFusion in Rust. Why we are currently we are working with both. We started with DataFusion because it was true open source. DuckDB, it's open source, but it's backed by a company. So, but yeah, we are using both, and they work both very well.
Okay, I'm joking. If you have another question, you can go for it.
I was just curious to know if you have any insight into why Pydantic chose DataFusion for Logfire. Like, have they shared any news
to be honest, I don't know exactly, but I'm really grateful to them because they are pushing us crazy on DataFusion. So they are closing a lot of issues I'm opening. So I'm very. but I don't know. I guess well, because at least well, there was just two. I mean, I think there are two main players in this world, that in this topic, DataFusion and DuckDB. I don't think there are others, so they just had to choose between one, and maybe they use the same approach that we use at the beginning. DataFusion is it's Apache foundation, so it's truly open source, while DuckDB, it's open source, it's a Linux foundation, but there is the main contributors are from one company. So,
but the icon is much better.
Yes. I have another part of the reply. Actually, they made a blog post about this, and originally they went with something a bit way different. They went with timescale, which is a Postgres time series extension, and their reasoning for switching to DataFusion was that basically originally they were trying to rely on a feature of timescale which is called continuous aggregates, which is like pre-aggregated views of the data computed automatically within Postgres, better than materialized views of Postgres. But they saw that their query patterns were very variable, so they had very wild query patterns, unexpected query patterns. So they went to something more raw, like pure DataFusion, rather than relying on pre-aggregation and stuff like that. So they decided to build their own databases instead of relying on a more stable solution. It's a nice blog post.
Okay. If there are no more questions, are you sure? We have Asper here. We are subject matter experts. Pizza. Okay. Thank you. A big round of applause for. And see you.